So let's look at a few. We're on section 8.2, sequence theorems and results, etc. Like I said, there's some simple stuff that we did back, arithmetic sequence adds the same number each time. So like adds or subtract a constant to get to the next term. That was arithmetic. I gotta get my pen out of here. Can't write. I can only talk right now. Anyway, so if we have an arithmetic sequence, I'm just going to show you an arithmetic sequence, arithmetic, a rat in the house may eat the ice cream. But anyway, an example of this would be like, 2, 5, 8, 11, etc. Basically, what we're doing to each term is we're adding 3 each time. So you might have learned something like this. And then the question would be, what's the value of the nth term? So this is n equals 1. The first term, the second term, right, or second element would be 5, have a value of 5. Value of the nth term is a plus n minus 1 times d, where d is the difference. So in this case, the difference is 3. N minus 1 is the value of the nth term, and then a is the value of the first term. So here's a, so a is 2. So this is 2 plus n minus 1 times 3, which if we multiply that out, that's 2 plus 3n minus 3, which is equivalent to 3n minus 1. So the value of the nth term is 3n minus 1. So if I say, hey, what's the value of the 100th term? You would say, well, just plug in 3 times 100, because n is 100, and then minus 1 is 299. So the value of the 100th term would be 299. So do you remember doing stuff like that? So this is the value of the nth term, okay? Something of that nature. So that's an arithmetic sequence, which I didn't write that out, but anyway. I'm gonna go quick. You can go back and if you want to write these down, if you want, but anyway. So anyway, if let's do another one. Let's do a geometric sequence. So geometric sequence, we're gonna multiply or divide, but you can also, dividing by 2 is like multiplying by 1/2. So we're going to multiply by some kind of ratio. So an example of this would be, 2, 4, 8, 16, etc., where to get to the next successive term, what we're going to do here is we are going to multiply by some fixed number. Sorry, I wanted to make that red. So I multiply by 2 to get to the next one, multiply by 2 to get to the next one, multiply by 2 to get to the next one, multiply by 2 to get to the next one. So obviously the next term is going to be 32, right? So to get to the value of the nth term, the question is, how would you do that? The value of the nth term is going to be a times r to the n minus 1 power. Okay, where once again, a is the value of the first term. So in this case, a is 2. And the ratio r is also 2 in this case. So this is going to be 2 times 2 to the n minus 1 power. Now in this case, this works out kind of nice because this is really 2 to the first power times 2 to the n, and same base, what do? We add exponents, so this ends up being 2 to the nth power. So the value of the nth term is going to be 2 to the nth power. So if I said, hey, what's the value of the n equals 100th term? So what's the 100th spot out there? In this case, it's going to be 2 to the 100th power. Well, that's a big number, right? What about the 10th term? What if I wanted the 10th term? That'd be 2 to the 10th power. So the 10th term out there, 2 to the 10th power, you double 2 10 times, and that's 1,024, just quick in my head, right? Because 2 to the 4th is 16. 16 squared is 2 to the 8th, which is 256. Double it twice, 512, 1,024. But anyway, that's 2 to the 10th power. Yeah, so I just know it, so it doesn't matter. 2 to the 9th is 512. 2 to the 11th is 2,048. I mean, it's just easy math. Just multiplying or dividing by 2. Double it or half it. But anyway, so that's the value of the 10th term. Of course, the value of the 100th term, 2 to the 100th power, that's a big-ass number. We don't, dang it, I'm on film. We do not have that. That would be too big for your calculator. So we just write 2 to the 100th power. But that's not generally what it is. Let's look at just a real quick another example. So let's just start with a different number. Let's just do, well, we can start with 2 again, but then we can say 6, 18, etc. Right? So here I'm multiplying by 3. So the ratio is 3. So in this case, a times r to the n minus 1 power, the a is the first term, is 2 times the ratio, 3 to the n minus 1 power. Okay, now we cannot multiply the 3 and the 2 together, right? Because 3 is raised to a power, 2 is not. Okay, so if I want the value of the 100th term, the value of that would be, in this case, 2 times 3 to the 99th power. Once again, a huge number, but we'll just leave it like that. Okay, so that's a geometric sequence. Once again, we could divide by 2 each time. That'd be the same as multiplying by a half and then put a half in for the ratio, etc. So we have arithmetic and geometric sequences. I kind of told you when I first started this section that you had some easy ones that we did back in grade school, right? But then we also have one called a figurative sequence. What does that mean? Figurative means figured out. So figurative sequence, you got to figure it out. So it could be like, 1, 1/2, 1, 1/4, 1, 1/8, etc. The question is, what would the next 3 terms be? Okay, so the next 3 terms, well, we got to figure it out. So what's really happening here is we have certain things going on. So we have every odd term for n equals 1, n equals 3, n equals 5. We have a constant term of 1. So for odd terms, there's 6. Here's n equals 7, n equals 8, n equals 9. So for the 7th and 9th term, those would also be a 1. Does that make sense? Assuming the pattern continues and we've got the right, we have enough. But then what I'm going to do is I'm going to look at the even terms along the way. So for the n equals 2nd term, the n equals 4th term, and the n equals 6th term, I've got 1/2, 1/4, 1/8. What type of sequence is that if we're just looking at that? Arithmetic, geometric? It's a geometric, right? So to get to the next one, we're going to multiply by a half, right? If I know how to multiply by that, or write it on here. So to get to the what number was that? 6? This is horrible. All right, this is the n equals 8th term. I multiply by a half again. So to get to the 8th term, it's going to be 1/16, right? So the question would be then, what's the value of the 100th term? Maybe we should do what's the value of the 99th term and the value of the 100th term and the value of the 101st term. 100th term and the 101st term. Okay, well, 2 of these are going to be pretty easy, right? What's the value of the 99th term? 1. Value of the 101st term is going to be 1. The question is, what's the value of the 100th term? Okay, well, what it's going to be like is, since we're skipping every other one, we could really consider these in pairs along the way, right? Whoops, pairs along the way, and they're paired up. So it's the right half of these pairs, and so which pair? It'd be the 50th pair, right? Of numbers, 1 comma, and then whatever that is with the geometric, right? The 1/2, 1/4, 1/8, etc. So really, it's like the 50th term of the geometric sequence, right? So it's like n equals 50. I'll use capital N equals 50th term on the geometric sequence. Okay, so basically it's A times R to the, and since I'm using a big N here because that's a different than little n, which is where you're at in the real sequence, the figurative sequence, it'd be this. So this A, of course, would be a half, right? So this would be a half times, the ratio is a half to the capital N minus 1 power. Now in this case, since it's the same base, we can add exponents, and this ends up being 1/2 to the capital N power, right? And of course, what would that be? That'd be 1/2 to the 50th power. So for the 100th term here, that would be 1/2 to the 50th power, or 1/2 to the 50th power, because 1 to the 50th power is 1, right? So you could rewrite it or write it in any way. So if I want the value of the nth term, now what was in here? What was capital N? Capital N was like your little n. Puberty's great on film. All right, but anyway, it's little n divided by 2, right? It's halfway out. So the 100th term out here to the right would be like this. It would be like the 50th one of the right half. So big N is actually little n divided by 2, right? So if I said, hey, what is the, and I'll try and use a different color so I can keep this on the screen. If I want to say, hey, what's the value of the nth term, little n, the value of the nth term in general for this sequence here, this figurative sequence, it would be one of two things. It would be 1 if little n is odd, and it would be what? It would be 1/2 to the n over 2 power, 1/2 to the little n over 2 power if n is even. So anyway, that's not very good, but let me just rewrite it. It would be, the value of the nth term would be 1 if n is odd, and it would be 1/2 to the little n over 2 power if n is even. Make sense? Of course, we could say this is equivalent to 1/2 to the 1/2 power is √2, quantity to the nth, right? Or 1/√2 to the nth power. I mean, there's a lot of different ways to write that. Make sense? So if I said, hey, what's the value of the 1,000th one? Well, it'd be 1/2 to the 500th power. Right? Okay. Anyway, that's some basic stuff before. Now, none of those sequences that I just gave you converge to anything. They keep getting bigger or smaller depending on how, you know, the second one, the figurative one, bounces between 1 and something that approaches 0. So the right half of that was a convergent sequence, right? Because the limit of that as n goes to infinity would be 0. However, because it had a 1 on every other term, it would be a bounded sequence, right? It'd have a least upper bound of 1 and a greatest lower bound of 0, right? So it would be a bounded sequence, but it would not be convergent, right? There's no particular limit that it approaches because it bounces between 1 and something getting close to 0 as n goes to infinity, right? So we can use some of those simpler examples leading into the other stuff that we had done. So none of that answers any questions over what we've done. I just wanted to tell you that probably as a kid you learned arithmetic, geometric, and figurative sequences. Well, what are we doing? We're trying to determine if it's convergent or divergent, and much like the end of chapter 7, if it's convergent, find its limit. Now, it says supported graphically, which, you know, remember it's a series of dots, right, for the graph, but you can do that if it's easy. I'm not worried about that right now because we're not plugging this stuff into graphing calculators unless you really want to. But anyway, if I have the sequence n plus 1 over 2n minus 1, okay, basically, and I want to know what's the limit as n goes to infinity. Well, I can just write that here. I'm looking for the limit as n goes to infinity of this deal. Okay, well, what dominates in this? What dominates in the numerator? N. As n goes to infinity, the n dominates that, and the 2n dominates the denominator. Okay, so what's the math trick? The math trick would to be divide every term by the biggest power. So that's what we want to do. We want to divide every term or numerator. And when you have a fraction like this, I'm just going to say divide by greatest power of n, or biggest power of n that you see. And so if I do it on top, I got to do it on the bottom. So the biggest power of n here is n to the first, right? So really, if I take the numerator and divide it by n, I'm just going to show this. I'm going to show it in excruciating detail the first time, and then we can just do it quicker. Anyway, but I'm going to divide numerator and denominator by n. So that doesn't change. That's good, right? That's legal because n is not 0. It's getting toward infinity. I can do that, right? And this is equivalent. If I take numerator, can't I do that? Because n over n really is 1, right? This is equivalent to the original, right? Like if you have 4/8, that's equivalent to 1/2 because you can divide numerator and denominator by 4. Yeah, so it's equivalent. So anyway, that's what we want. And then we're going to use laws of fractions here. And so laws of fractions, this is equivalent to divide each one. So it's n over n plus 1 over n in the numerator. Everybody agree? And then in the denominator, it's 2n over n minus 1 over n. And so it's equivalent to this, right? So we're just looking at this sequence in here is equivalent to this. Of course, now this is equivalent to 1 plus 1 over n over 2 minus 1 over n. Everybody agree? So what was the advantage of that? The advantage of that is now I can take the limit as n goes to infinity of this thing, right? And if I do that, what's the 1 over n go to? 0. And what's the 1 over n in the denominator also goes to 0. So what am I left with? 1/2, right? So the limit as n goes to infinity of this thing equals 1/2. So it's a convergent sequence, and it converges to a limit of 1/2. Now we can use epsilon delta on this to prove it, because now that we know the limit, we can say that the difference of this sequence and 1/2 is absolute value of that difference is less than whatever epsilon you give me, and we could prove that using the methods of Calc 1. And Isaac said he doesn't like doing that, but Jordan's really good at it. Remember that? We had that conversation earlier today. Not on film, but now it's on film. Huh? Am I violating FERPA laws by saying first names of my students? FERPA. I don't know. That's some kind of privacy. If you want your life to be private, don't use social media. Thank you. All right. You heard it from somebody. Anyway, move. Well, yeah. I mean, is that the answer? I hadn't shown you that. I mean, I showed you earlier, but like you may not have remembered that strategy. You well, right, and you can start listing it out, right? I mean, if we're listing that out, you plug in n equals 1, and you get 2 over, right? Let's just do that because we had n plus 1 over 2n minus 1. I mean, it may be obvious, but it might not. If you're listing out the elements, n equals 1 would be 2 over whatever, 4 minus 3, 2/3. N equals 2, we got 3/5. N equals 3, we got 4. Wait a minute. 3 what? 2. What? Plug in 1. 2 minus 1. Right. So it's 2. That's what I said. This time. And then plug in 2. N equals 2. We get 3/3, which is 1, right? That's 1 for the second one. N equals 3. 4/5. N equals 4. What? Dang it. Yeah, this is n equals 3. What's n equals 4? 5. You do the deno. 8 minus 1, 7. What? So what's n? I mean, this is n equals 1, n equals second term, n equals 3. So you're plugging in 3 everywhere there's an n. So 6 minus 1 is 5. I don't know what you're doing. I thought I had that right. And then what about n equals 4? If I plug 4, 8 minus 1 is 7. All right, but anyway, 4/5, 5/7, etc. Now, can you tell what that goes to? Not really, but if you keep going and let n go to infinity, I just proved that the limit is going to be 1/2. Right? Makes sense? Because of what dominates. If you were graphing this as a function, that would be a horizontal asymptote out wide for huge x's. So you actually had those methods back in graphing theory and algebra, right? When you were graphing rational functions, which you didn't know how to do, but we did it back in Calc 1, I think. Anyway, all right. So, everybody good with that? So let's just do number, what do you want, number 3 or number 4? Should we do number, I'll do number 4 because you got some odds there, although you're not going to know if the answer's right. We like, did it say 1/2 for the limit? Okay. Well, let's look at number 4. Number 4 is a little different. That's 3n cubed plus 1 over 2n squared plus n. Well, once again, what's the biggest power of n? In this case. So if I'm taking the limit as n goes to infinity, it's into what power? N cubed, right? So you got n cubed, n squared, and n, right? The biggest power is n cubed. So we're going to divide everything by n cubed, numerator and denominator. But if I do that, I got 3n cubed over n cubed plus 1 over n cubed, right? Because of the laws of fractions. So now I'm shorthanding my work. I'm taking numerator and denominator divided by n cubed, and then I'm using laws of fractions to split it up. Ultimately, it comes down to take every term and divide it by the biggest power. And that's mathematically equivalent, right? Because of laws of fractions. Correct? So we got this. Now what happens? What's this equivalent to? So this is equivalent. I haven't taken a limit yet. Limit as n goes to infinity of, well, what do I got on top? The n's cancel. N cubes cancel, and I got 3 plus 1 over n cubed, right? And on the denominator, I've got 2 over n plus 1 over n squared, right? Sorry, I don't really need those. I thought that was parentheses. Everybody good? Now, if I let n go to infinity, what happens? Yeah, but what do I got on top? I got a 3. I got 3. I'm approaching 3 in a positive way, but 3 is a positive number, so it doesn't really matter. But anyway, so if I come up here and I let n go to infinity, is basically what I'm doing. Now I get 3 on top, and on the bottom, this goes to 0 and that goes to 0, right? So it's 0 plus 0, which is 0. But what kind of 0 is it? It's a positive 0. Now we got to be careful, because if I had a minus sign in here, then it'd be 0 minus 0. Then you're not quite sure what type of 0 it is. You got to be a little bit careful, and you have to evaluate that, right? But anyway, a positive fixed number divided by something approaching 0 in a positive way goes to what? Positive infinity. So this limit of this sequence continues to explode upward toward positive infinity. Now, what does that mean as far as the type of sequence it is? It should be considered divergent if they want to match what divergent meant and other stuff, right?